Hi, my name is Cooper. I'm a math teacher and a data scientist, and I love to talk about math and statistics. We all know about probability. We deal with it every day. Probability describes the likelihood that an event will happen. Whether we're watching the Weather Channel and deciding if we need an umbrella for the day, or sitting at the poker table deciding if we should hold 'em or fold 'em. It all comes down to probability. But what do we really mean when we say there's a 20% chance of rain or there's a 25% chance I'll win this poker hand? It turns out that the interpretation of these statements and other probabilistic assertions is flexible and can depend on the specific event that we're talking about. In general, there are two main interpretations of probability: the frequentist interpretation and the Bayesian interpretation. It really just depends on the event we're talking about, as well as the opinion of who's talking about it. Let's have a closer look at each of these interpretations. The frequentist interpretation describes probability in the context of what would happen if the same scenario were to be repeated over and over again. How often would the event we're talking about actually happen successfully? This interpretation makes a lot of sense for scenarios that are easily repeated, such as flipping a coin, rolling a six-sided number cube, or dealing out 5 cards from a deck. If you were to flip a coin 10 times, how many heads would you expect to get? You might get exactly 5 heads and 5 tails, but you might get 6 heads, or even 3 heads. In fact, you might not even get any heads, but that would be pretty unlikely. By dividing the number of heads you get by the total number of flips you make, you can get a pretty good idea of what the true probability of getting a head would be. So, let's say you got 4 heads after flipping the coin 10 times. You might approximate that the probability of getting a coin to land on heads is 0.4. But we all know that's not really the case. How can we get a better estimate? Well, we could try flipping the coin more times, a lot more. In fact, the more times we flip it, the closer our approximation will get to the true probability value. We can use software to simulate tosses of a coin using a random number generator and see the result of 10 tosses, 100 tosses, even 1,000,000 tosses. You'll see the result of our experiments getting closer and closer to 0.5. But what about events that you can't easily repeat? What if I want to know the probability of whether or not it will rain today? I can't just make days appear out of thin air and then start counting the ones with rain. I could look into the past and see how many days it rained, how many days it didn't rain, and make my prediction that way. Does this seem like a good idea? Well, not really, but why not? Some events are just too unique in terms of the context and surrounding factors to simply repeat over and over, or even to simulate repetitions for. Things like the weather, sporting events, financial risks. A lot of things rely more on information and our beliefs about the uncertainty of a potential outcome. We call this the Bayesian interpretation of probability, basing our idea of probability on what we believe the uncertainty of success is. There are advantages and disadvantages to both interpretations. Frequentists can easily approximate probabilities by running experiments or simulations, but they can't always get accurate probabilities for events that only happen once or depend on many external factors. Bayesians might use a little more judgment and subjectivity when it comes to making predictions about probability, which isn't great from a scientific point of view, but the nice thing is that we can have access to assigning probabilities to a more diverse class of events with this interpretation. In the end, it doesn't really matter what point of view you take. The rules of finding and solving for probabilities will be the same in both cases. It's really more of a philosophical question than a practical one. So, which interpretation do you like more? Are you a Bayesian, a frequentist, or maybe a little bit of both?